Welcome dear our friends. Today I discuss algebra second classes, set theory and real number system. We request to all students to see previous classes for more clarifications. Okay. So now we proceed. Next topic, set theory from is next topic is a power set, and we discuss power set. Okay. Sleep power set means we try to understand power set through examples. Suppose an example A. Suppose A equal to 1, 2, 3, 4, 5 and okay. Then the power set of A we expressed, or we can write power set of A as a singleton set as 1. Firstly we write singleton set. All elements of singleton set of this set contain in a power set. Okay. So firstly we write all elements singleton set 3, 4 and 5. Now we write double duplex element set 1 2 1 3 and so 1 5 1 5. Similarly 2 1 2 2 and 1 1 we not write. 1 1 we also write 1 and 1. Okay. With other elements similarly is 2, last is a 5 and for 3 and and 1 2 3 4 4 similar as 4 4 1 4 1 is and next last is 4 5 4 4 and last elements 5 1 for last element 5 1 5 2 and so on and 5 5 and for more elements 1 2 3 1 2 3. Okay. And for fourth element set 1 2 3 4 and 1 2 3 4 4 and 5 is the last set. Okay. मतलब कि इसमें कहता है सारे एलिमेंट का सबसेट होता है, मतलब सारे सेट्स होते हैं यहाँ पे. ठीक है. सभी सबसेट्स होते हैं यहाँ पे. ये तो बहुत ज़्यादा एलिमेंट ले लिए थे, इसलिए एक छोटा एग्जांपल लेने की कोशिश करते हैं, उससे इजीली समझ में आएगा. जैसे देखेंगे, if you not understand, we try to buy a smallest set 1 3. Okay. Then power set of A contains all those subsets of A 1 1 3 1 3. Next 1 3 and last is this set is also contained in power set. That means सभी सबसेट इसमें होते हैं. और एक चीज यहाँ पे छूटता है कि 5 also belongs to in A, so here we write also 5. Okay. यहाँ से एक चीज देख सकते हैं कि टोटल नंबर ऑफ सबसेट्स कितना होते हैं. तो उसके लिए क्या किया जाता है, टोटल नंबर cardinality, this represents cardinality of power set. That means total number of subsets of A is a general formula 2 to the power n. N represents number of elements in set A, in set A. Okay. इसका मतलब क्या हुआ कि पावर सेट क्या होता है कि सेट्स का, ऑल सबसेट्स का कलेक्शन होता है, फैमिली ऑफ सेट्स हो रहा है, ठीक है। तो उसी तरह से हम लोग क्या करेंगे, पावर सेट का डेफिनेशन लिखेंगे, ठीक है। दैट्स इट, 1 मिनट। पावर सेट, okay, we discuss power set, the theory. Power set is the set, or is the set, power set is the set or the family of, or the family, or the family of all the subsets, all the subsets contain of the given set A. Okay, this is called power set and is denoted by of the given set A is called, or said to be, is called power set of A. It is denoted by, it is denoted by, it is denoted by P of A. P of A, capital P of A, that means power set of A, and we generally represent in symbolically, or mathematically we say symbolically, sorry, I yes, symbolically or symbolical, represent symbolically or symbolical power set of A. In this set, power set is also set. So power set contains two elements, that means two set, such that X belongs to A. Okay, मतलब पावर सेट में वो सेट होंगे जो X में X का सेट होंगे, मतलब सबसेट भी बोल सकते हैं, सॉरी ये तो एलिमेंट हो जाएगा, which is subset of A. Okay, and we write other thing, total number of cardinality is here, right? Also one point is here mentioned. We can also say that one point, if X belongs to power set of A, when belongs to power set of A, if and only if X is a subset of A, and cardinality is here mentioned, and this is a, for example, this is example of power set for understanding. Okay, next one point also here mentions phi. If phi belongs to, also phi belongs to in power set of A, this means this is a universal truth for all sets, and A belongs to power set of A for all sets, for all sets. Okay, and next topic we can see more examples. One another examples: 1 2 3 1 1 1 2. Yes, first example and second example we see. We can take a set B, a set B 1 2 and 3. Okay, then power set of A, then power set of A, sorry, B, power set of B is, we write, firstly we write 5, firstly we write 5 because 5 belongs for every sets, 5, and singleton set 1 2 1 2 3, and duplex sets 1 2 and 1 3 1, sorry, next 2 1 2 1 is right here, 1 2 is here, elements also mentions, so 2 1 is not right in again. Okay, so only we write 2 3 2 3. 2 1 is not right because 1 2 elements also mentioned. Here we can write one things. You can see why we not write 2 1, because in a set, suppose A 1 2 1 2 is a set, 1 2 elements in a, and other set suppose 2 1, and we read a in a equal sets. If all the elements are set in two sets, then these sets are said to be equal sets. Okay, same elements, because one is here present in the set A and one is also present in B, and two elements is present in set A and two also present in the set B, so both sets are equal sets. So so these reasons we not write here 2 1. Okay, clear? And next sets for third element set, three element sets 1 2 3. So we write set A set A, that set B 1 2 3B. Okay, this is the final. Now we can count total number of elements in a power sets. This satisfy or not? Power set of cardinality of, that means total number of sets subsets in B is 2 to the power n. N is the total number of elements is a 3. That means n equal to 3. So we write 2 to the power 3. So that means 2 to the power 3 is 8. Now we can count here 1 2 3 4 5 is a one set, 5 6 7 8. Okay, so this is a right, this is true for the power set of B. And next we see, and one note point, A is a subset. Next you can write a note point. First, this one is a first, second, third, and fourth point we can write here. First we have fourth point, if A is a subset of B, this implies power set of A is a subset of power set of B. Okay, this is universal truth. And next topic we discuss universal set. What is universal set? We try to understand a universal set from the examples. Okay, supersets of all the sets under. Now we discuss universal set. through the example. Firstly, we take example for universal set. Universal set. Okay. Universal set. Try to understand the universal set through examples. Suppose let us set A or U. Universal set generally represent by U or any letter. You can also representations through any letter, but here we represent U. Suppose 1 0 1 2 3 4 5 6 7 8 9. This is the all digits, all single digits 0 to 9. Okay, so here are 10 digits. Now we can see, suppose we let a example another set 0 1 and B is just another set, suppose 2 6 2 4 6 8 or okay, and C is a set 0 1 or we write generally 1 2 3 4. Here we see A is all the elements set of all the elements of set A 0 1 elements belongs in set U, and similarly we see B elements in the set B, all elements of B 2 4 6 8 2 4 6 8, that means all elements of B also contain in U, and similarly we see for 1 2 3 4 1 2 3 4 1 2 3 4 are also in U. That means all these three sets, set A, set B, set C, generate from universe set from U. So set U is called universal set for sets A, B and C. That means जो हम लोग सेट डिस्कशन के लिए यूज करते हैं, देखिए यहाँ डिस्कशन के लिए यूज किए हैं सेट ए, सेट बी, सेट सी, तीनों को हम लोग क्या यूज किए हैं, तीनों को हम लोग सेट यू से ही जनरेट किए हैं, इसलिए यू को हर जगह यूज किए हैं हम लोग। जब हर जगह यूज किए हैं इसलिए हम लोग उसको क्या कह सकते हैं कि वो जो यू है मेरा वो यूनिवर्सल सेट है, ठीक ना, यही कहा जा सकता है। यहाँ पे हम लोग एक डेफिनेशन लिख सकते हैं। हम लोग इसके डेफिनेशन ऐसे लिख सकते हैं, अगर डेफिनेशन लिखना चाहें तो सिंपल जनरल डेफिनेशन लिख सकते हैं कि द सेट which set generally we use the set which is used, okay, the set which is used for discussion discussion of given sets, okay, this is called universal set, okay. And other examples, other definitions. other definition other definition, the set which is superset superset of all the subsets or sets under considerations under consideration under consider under consideration is known as is known as universal set and denoted by universal set denoted by capital S or U. Okay, this is our definitions. That means जिस सेट को यहाँ से देखिए, द सेट विच इज सुपर सेट ऑफ all the sets under considerations is known as universal set and denoted by S और U. जनरली यूज सुपर सेट हम लोग लास्ट क्लास में डिफाइन कर चुके हैं, ठीक है, इसका डिस्कस हम लोग कर चुके हैं. क्या कर रहे हैं, इसका डिस्कशन अंडर कंसिडरेशन, वही लिखे ना, अंडर कंसिडरेशन इज नोन एज. इसी के कंसिडरेशन में क्या कर रहे हैं, ये सब सेट हम लोग जनरेट किए हैं, ये सब सारा सेट इसमें बिलोंग कर रहा है. दैट मीन्स ऑल सेट्स आर बिलोंग्स इन all the elements of these all sets ABC contains in a set U. Hence U is a universal set. वही यहाँ पे भी लिखे हैं कि the sets which जो हम लोग डिस्कशन में यूज करते हैं, used for discussion of given sets, A B C are all given sets यूज करते हैं, उसी को हम लोग क्या कहते हैं, यूनिवर्सल सेट कहते हैं. ओके, नाउ नेक्स्ट वी प्रोसीड Venn diagram. Venn diagram. Now we discuss Venn diagram. Venn diagram. Venn diagram. Venn diagram. Venn diagram means जनरली हम लोग क्या करते हैं, यूज करते हैं सेट्स का रिप्रेजेंटेशन के लिए, ठीक है, उसी को क्या कहते हैं, वेन डायग्राम. दैट मीन्स most of the relationships between the sets can be represented by means, that means defined meaning of the all the sets, all the related sets is known as Venn diagram, represented by Venn diagram. Okay, so we write firstly definition, or you can also we can see firstly we say a diagram. Suppose this diagram, this is a set A, this represents set A, and this representation a set B, and this is a universal set. This is a universal set. You can write any plus U. Okay, this is a universal set. That means representations, relations between this and this sets, all three sets represent through a diagram. This is called Venn diagram. Okay, so Venn diagram most of the relationship most of the relationship most of the relationships between between the between the sets between the sets can be represented by mean represented by diagrams means of diagrams which are known as or which is known as Venn diagram. Venn diagram. Okay, मतलब and denoted by in Venn diagram and denoted by in Venn diagram as universal set as universal set denoted in Venn diagram as universal set by rectangles and other related sets other related sets by circles okay, that means all the relationships most of relationship between the sets between these sets and these sets can be represented by means of diagrams. We represented by this relationship of the sets. Also, we can here represented through intersections of both sets. Firstly we write here in a not intersection simply, and other we take other examples. This is a universal set, and suppose here a intersection be also present. That means this is represent the relationship of A and B and U. Okay, all three sets of representations here, relationship here represent through the diagrams. So this is known as Venn diagram. Okay, मतलब ये सब क्या कर रहा है, हम लोग जितना भी इसमें कुछ काम कर रहे हैं ये इंटरसेक्शन बी का, उसको रिप्रेजेंट कर रहे हैं थ्रू डायग्राम से, उसी को बोलते हैं वेन डायग्राम. ओके, और इन द यूनिवर्सल सेट्स represented by rectangle and other related sets are denoted by circle. Okay, so here we mention next some properties. We say what are mentions properties or any other things. No, we can see one examples here given a one examples. Not operation on sets. Next topic, operations on sets. Venn diagram used in our next topics used for calculations. Also we can use in these problems Venn diagram use A union B. When we use Venn diagrams, generally we see A union B, A and B unions. Unions means A and B. We discuss in a unions after in the operations of sets. A union B. Suppose A, what is the A union B? A union B means collections of all these members, all these elements of set A and set B once times. Okay, that means generally we say a set, a set A union B, A union B collections of the those elements, those elements in A union B which are belongs to either x belongs to A or x belongs to B. We represent through the diagram here. Okay, that means these portions, only these portions represent A union B. Here diagrams of portions, color portions represent A union B. We can say A union B represent only colorful diagram. Okay, so now we discuss operations on sets. Operations on sets. Operations on sets. Operations on sets. First topic in operations in sets, union. A union of two sets. Okay, union of two sets. Union of two sets. Union of two sets. Firstly, we see examples, then define a definition. Suppose let A is a set, A is a one set 1 2 3, and B is another set, B is another set 2 3 4, and 0 also here include. Okay, now then how we define A union B? A union B means, now A union B means in this is a new set, suppose C, union set C, that means A union B. We assumed A union B is a new set, that means A union B is treated as a set, contains A union B in the set contains all those elements either in A or B, right? Only once time. So firstly we write 0 here, and 1 2 3 4 and 5 is not in any sets. This means here clearly we see 0 either belongs to A or either belongs to B. Here see 0 belongs to in B but not in A, so 0 not belongs to A. अगर आप अपने वे में देखना चाहें, हम लोग बोल सकते हैं कि A यूनियन B एक सेट ही है, जिसमें क्या होता है कि A और B का एलिमेंट होता है. All those elements contain all those elements which are belongs to in A और B, मतलब A में भी हो सकता है और B में भी हो सकता है. ओके, ये कहना चाह रहे हैं. और उस सबको एक ही बार लिखना है, ठीक ना? ऐसे नहीं कि इसमें आ रहा है 1 2 2 3 इसमें आए 2 3 इसमें, तो डबल लिख देंगे, ऐसा नहीं. once we write. Okay, now we define definition. इसको समझ में आ जाना चाहिए कि ये यूनियन भी क्या होता है. all those elements contains करता है all the elements of A and B either in sets A और B और in both, दोनों में भी हो सकता है. so union of the union of two sets, union of two sets A and B, union of two sets A and B contains all the elements, all the elements of A and B, which is either in A or in B or in both, that means hereby understand through examples. In the union set contains all those elements of A and B which is belongs to A or B or in both. Here we see 0 in P, 1 is 1 in A, 2 in both, 2 and 3 in both, 4 in B. Okay, this is our definitions. Clear through the examples? We can also see another examples. X is a prime number less than 10. Example, or we can write, for example, let's A is a set X such that X is a prime number. X is a prime number which prime number less than 10. This is set A and set B. The element X such that and X belongs to -5 greater than and less than 5. This means X is greater than -5 and less than 5. That means we can write A is the element. We explore prime number less than 10. So we write prime number 1, 3, 5, 7. Not 11, right? Because less than and set B. And in set B, X is a element belongs to integer number such that x belongs to -5 to 5 integer numbers. That means set B we can write here not take integer numbers, so we write -4, -3, -2, -1, 0, 1, 2 and 3, 4. Sorry, 5 is not included in this because x is less than 5, so 5 is not included. Now we write A union B. That means firstly we write all those elements write in a single times: -4, -3, -2, -1, 0, 1 and 2 is here and 2 is also here, 3, 3 in both sets, 4 is only B, 5 and 7. Okay, this is a union of A union B of for these sets. Okay, मतलब ये इसके लिए था और ये इसके लिए है, ऐसे समझना है, ठीक ना। ये हम क्लेरिफाई, ये समझने के लिए हम लिख दिए हैं। सो नेक्स्ट द properties of union sets. Properties of union sets we write A union B. First is the properties of union set. Properties of union of union sets. We write the first property is if x not belongs to, or if x not belongs in A union B, this means we say then, or this means this means x not belongs to A union B. This means A neither belongs in A or not belongs to B. That means x is not the elements of A and B. That is, we also write x is not the member of A or x is not the member of B. Okay, this is clear. Next, A is a subset of B. Here write and. Next property is if A is a subset of B. This implies when we take A union B, then what is the here? Right. Here we conclude A is a subset of B, means A is a subset of. Suppose we take one example 1, 2, and other set is a 1, 2, 3 and 5. This is set A and this sets B. Then how we write A union B? 1, 2, 3, 4 is not here in the box. 1, 2, 3 and 5. 1 is here, 2, 3, 4. Okay. Now we can clearly, here we see clearly 1, 2, 3, 4, 1, 2, 3, 1, 2, 3 and 5 also. This means this is represent set B. So A is a subset. Here we see A it contains in this set. All the elements contained in the set B. That means all the elements of set A contained in set B. This say A is a subset of B. Means then we see A union B is B. So here we write B. Okay. And next, A union B is associative, commutative law also follow, and associative law also followed. Okay. So we write associative commutative law. A union B equal to B union A. This is our commutative law. Commutative and association law also followed. Means A union B union C. In the three sets. Firstly, we can write A union B, then we write A union C. or also we write firstly we write B union C, then after this you write A union C. This is associative law. Or also we write for this A union B union C. That means here first we write A union B, then we write C, and also this write B union C. Then after this we write A union in the last. Okay, this is a associative law. Associative 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 law. And next is a next property. A is a subset of A union B, and next A is a subset of A union B, and B is a subset of A union B, because elements of A also contain in A union B, and elements of B also contain in A union B. So B is also subset. That means A is a subset of A union B, and B is a subset of A union B is always true. And next property is phi union A. Phi, how we write phi union A? Phi union A. Phi union A. And also we can write A union phi. What is this gives? When we write phi union A and A union B, A union phi, then what is this gives? Phi in null sets. That means no any elements in common. No any elements in common. That means only we write here elements of A. Okay. अगर नहीं समझ में आ रहा है तो एग्जाम्पल ले लीजिए. We take one examples. Suppose A is 1 and 2 and phi is a null sets. That means void sets. No any elements is here are present. That means when we take A union phi, A union phi means write all these elements in this and this are present. So 1 and 2 are here present. 1 and 2 are present, but here no any elements, so we nothing write. That means this is a represent set here. This also represent set here. Okay, so here this properties. That means this property is final. Means here the one properties, second properties, and our third properties is associative law, and this is a commutative law, and this one, and this is our first properties. Okay, so all properties are mentioned. Now we see next topic, union, and now we take intersections. Okay, intersections of two sets. In operation sets, intersections of two sets. Second topic for operations on sets, intersection of two sets. Intersections of two sets. Here we take a first examples. A equal to 1 2 1 2 and set B equal to 1 2 3 5 and 6. Then how we write A intersection B, and second example we take A equal to 1 2 3 and 5 6 8. 1 2 3 and set B equal to 5 6 7 and 8. Then what is the value of A intersection B? And third example, we take 1 2 3 1 2 3 to 6. A equal to 1 2 3 and another set B 1 2 3 4 5 6. Okay, then what is the set B? Then what is the set B? We take one more examples. Yes, now here we see intersections means listen carefully. Intersections means A intersection B means here write those elements which are common in both, that means contain in a both sets. Here write those elements contained in both sets, that means one here contain in a and one contain in a B, that means in both sets present. One is present in a both set, two is also present in a both set, but three is not present in B but present in, sorry, 3 is present in B but not present in A. 5 and 6 also not present in A. So we not write here. That means we define A intersection of two sets. Intersection of two sets, we say that the common elements, that means common in both sets A and B. Similarly, we write in the common elements 1 nothing's common, 2 is nothing here, 3 is nothing else, 5 6 7 also in not included A. That means here represents void sets or null set. Void sets, that means no any elements here we write. Okay, and in this set 1 2 3 1 2 3 contains in set B, so we write 1 2 3. Now you can understand the intersections of sets. So these three examples, one another examples, we also take one examples, one fourth examples. Here we give hen sets A 1 2 3, sets B, sorry, okay, sets A 1 2 3, sets B 2 4 6 and C 1 2. A is a set 1 2 3 and B is a set 2 4 6 2 4 6, yes 2 4 6, and C is a third set 1 2 which contains 1 and 2 elements. Okay, now we can write how we can write A intersection B intersection C intersection. Okay, that means here we write those elements which are common in all three sets. One is here but one not is in B, so not we write here, not we write here 1. 2 is common in this, 2 is present in G, also present in B and also present in C, so we write 2 here. 3 we see 3 here but 3 is not here, so we not write, so only common one elements 2. Okay, this is our intersection representations. Okay, now we write definitions of intersections. Here the definitions write the intersection of sorry intersection right, see intersection of two sets or more sets, two sets A and B, or more sets the intersection of two sets A and B or more sets is the sets is the set or is contains, we also write intersection of two sets A and B is the sets which contains all the common elements, common elements only, common elements only is called intersection of sets and is denoted by ये intersection B. Okay, and symbolically or symbolical, we write symbolical. ये intersection B is a new set. ये intersection B is a new set contains those elements in A intersection B such that A belongs to A as well as, that means, and X belongs to also in B. Okay, this is our representations of sets, and we say if one property is, we write if X belongs to, here we see if X belongs to A intersection B, this means if and only if, or this means if and only if X belongs to A as well as X belongs to B is mandatory. Okay, now we write properties of intersection of sets. This is our clear. Now first we refill ink. First property is if X belongs to, first property is X naught belongs to A and X naught belongs to B, then this means X naught contained in A and X naught contained in B, that means not present in A and B both. Then what we write? Union of, then also X is not belongs to in A intersection B. This is in general form. In general form, X not belongs to A1 intersection, A2 intersection, A3 intersection, intersection AN. This means that is, then we say then X is not present in all sets. अगर आप लोग को वीडियो धीरे धीरे लग रहा है कि बहुत धीरे धीरे बोल रहे हैं तो आप लोग फास्ट करके वीडियो देख सकते हैं, ठीक है. इन अ second property is if A is a subset of A intersection B, this means we say A intersection A is a subset of A intersection B. This means A wholly contain, that means all elements of A contain in A intersection B. That means then we write A intersection B is common all elements of A, only A elements, all elements of A B. Sorry, कुछ और तरह से दिया हुआ था, हम कुछ और तरह लिखनी है. In book given properties A is a subset of B, A is a subset of B, then intersection of A B is because A wholly contains in set B. That means we say A is wholly contained in B, so comments only elements of A. Okay, this is also a new properties, but this is in our book given. Okay, this is also true. Properties number 3 say A intersection B, commutative law is satisfied and associative law is also satisfied. Okay, commutative law means A intersection B equal to B intersection A, and associative law for points A intersection B intersection C. We can also write firstly A intersection B, then write intersection C, and also we write firstly B intersection C, then we write intersection A. This is our commutative law, and this is associative law. This is our associative laws. And fifth property is given. A intersection B containing is a subset of A, and A intersection B is also subset of B. And sixth property is union. That means De Morgan's law. No, A union B intersections, given intersections or not? Yes, A union B, firstly gives A union B intersection A. Here we see A union B means in this set contains all elements of A is here present and A is intersection. That means when 1, 2, 3, set A is 1, 2, 3, 4, 5 and contain 1, 2, 3, then what is contains in this? Suppose set B, and we can say set A is 1, 2, 3 elements contained, but in set B 0 to contains 6 all elements here. Okay, so now we when union take A union B, then 0, 0, 1, 2, 4, 5, 6 also is here mentions. Now then contains intersection of these sets only common element 1, 2, 3. That means set A contains 1, 2, 3. So here we write only A. Okay, and similarly for B, and similarly for set B, A union B intersection B B is here contains B is here contains, so we write here set B. And other properties, if intersection is here A intersection B union A intersection B union A, that means firstly we write common elements of B and union, okay, and union A. Here we observe A intersection B, that means common elements of A is here present, and with union A, that means on here firstly here presents elements A and we take union with A. Also present here, firstly present here elements of A, and also here all elements of A is here present. That means common element of A is present here, and also union with all elements of A. That means this is a subset of A. That means A intersection B is a subset of A, and this subsets intersect with A. So this gives A. समझ गए होंगे? Okay. That means here we write A. Similarly for B, when A intersection B, we take union with B. That means here present element of B, common elements with A present here B elements common with A is present, and all elements of B is present here, so we write here only B. Okay. And next property is distributive law. Yes, distributive law. Yes, distributive law gives. That means when A intersection B, when A union B intersection C, how we write A union B intersection C? Then firstly we take A union B. Firstly we take A union B, and then intersection apply with A union C. A union C. And other is right if you write A intersection. Suppose intersection in outside and union with C. Then similarly we write A intersection B. Firstly we write A. That means we operate A with B. So operations is our main operation is intersection. So A intersection B. That means operations with both one by one and union in given. Now we take intersection C. Same as here, right? This is our distributive law. This is distributive law. This is our distributive law. Distributive law. Okay, this is our distributive law. And now intersection properties of enough. And now disjoint sets. Now discuss disjoint sets. Now we discuss disjoint sets. अगर आप लोगों को वीडियो सोलो लग रहा है तो वीडियो का स्पीड बढ़ा करके आप लोग देखिएगा. ओके. Now we discuss disjoint sets. Disjoint sets. If two sets are given, then when we say disjoint sets, we try to understand disjoint set. Disjoint sets. We take one examples. Try to understand disjoint set. So what is disjoint sets? And another set. First set 1 2, set B 0 4 0 4 5. Here we see or observe no any one elements common here. That means A intersection B is 5, or we write no any elements common here. That means if we say disjoint sets, if x not belongs to A as well as x not belongs to B, this implies we write symbolically A intersection B is equal to 5. This is then we say what? Then we say A and B are disjoint set. Okay, A and B are disjoint set. That means we write the definition through these examples. If A intersection B equal to 5, A intersection B equal to phi, that is no any elements are common, no any elements are common between B oblique W is read as between A and B. A and B. Then this set is then A and B are said to be A and B are disjoint set. A and B are disjoint sets. ओके, ये एग्जांपल तो यहाँ दिया हुआ है. नेक्स्ट हमारा दिया है डिफरेंस ऑफ सेट्स. डिफरेंस ऑफ सेट्स डिफरेंस ऑफ सेट्स, ये कोई हार्ड नहीं था. डिसजॉइंट सेट्स तो कॉमन एलिमेंट्स नहीं होना चाहिए, ठीक है, वही होता है. सॉरी. ओके, डिफरेंट ऑफ सेट्स. डिफरेंस ऑफ सेट्स. डिफरेंस ऑफ सेट्स. difference of sets. This is difference of sets. Now difference of sets, we take firstly examples. Let A equal to 1 1 2 3 and another set B 1 2 3 4 5. How we differentiate A minus B equal to, okay, and A minus B equal to, both are right. A minus B means from the set B subtract set A. From the set B subtract set A. That means all those elements here we write which are after cancel out these elements, okay, all those elements of A which are not in B. मतलब A का सारा कॉमन एलिमेंट यहाँ पे कैंसल आउट कर देंगे, सब्ट्रैक्ट कर रहे हैं. दैट मीन्स एलिमेंट ऑफ A कैंसल आउट फ्रॉम द सेट B. So only left 4 and 5. Similarly here A minus B cancel out only those elements of set A. Set A, listen here, set A subtracted, set B subtracted from set A. That means cancel out in set A those elements which are in common. So 1 2 3 are present here, 1 2 3 present in set B also. So all three elements are cancelled out. So here is only not any elements left in ये. okay, मतलब B का वो सारे एलिमेंट कैंसल आउट होगा A से जो कॉमन होते हैं, ठीक है, ये चीज बोल रहा है. तो यहाँ पे सारे एलिमेंट कैंसल आउट हो गया. और B में जब सेपरेट किए थे 1 2 3 4 5 से, तो 1 2 3 कैंसिल आउट हो गया, बचा क्या 4 5. तो 4 5 लिख दिए. यहाँ क्या हो गया, ओनली 5 हो गया. नॉट एनी एलिमेंट्स है लेफ्ट. ओके, 4 5 नहीं लिख सकते हैं, ए में सेपरेट कर रहे हैं ना, तो जो जो मिलेगा उसी को यहाँ पे सेपरेट कर सकते हैं, ठीक है. यही हम लोग लिख सकते हैं. तो हम लोग लिख सकते हैं डेफिनेशन. सो वी डिफाइन द डिफरेंस ऑफ टू सेट्स. The difference of sets A and B A and B, A and B, difference of A and B is the sets is the set contains all those elements, all those elements of A which is not present in B and is denoted by A minus B. Symbolical we write A minus B is a set, another set contains those elements such that X belongs to A but X not belongs to B. Okay, this is our symbolical representations. Next topic and next sets. Yeah, properties of difference of sets. So here we write, after this properties, write properties of different set. First property is, if A minus B equal to 5, then what we say? A minus B equal to 5. This means no any elements of set A present in set B. मतलब कोई भी A का एलिमेंट सेट B में प्रेजेंट नहीं है. So that is, we say no any elements of set A are present in or belongs not belongs. No any elements of set A are in set B. Okay, ये चीज हो गया. That means no any common elements, or we say no common element. कोई कॉमन एलिमेंट्स नहीं है. Second property is given, if A is a subset of B, then if A is a subset of B, this means all the elements of A, set A contains in set B. Then what we write? And what is the value of A minus B or B minus A? A minus B. Because all elements of set A contain in set B, then A minus B. That means all the elements belongs in set B. So all the elements subtracted from set A. So we left null. And next property is, X is not the element of set A minus B. When we say X is not the element of A minus B, X is not the element of A minus B. When we say X is not the element of A minus B, when we say if X belongs in both set, then subtracted out or cancel out from A minus B. Then if A belongs to A and X belongs to A and X belongs to B, जब X हमारा दोनों में होगा तभी A minus B का नहीं होगा क्योंकि वो cancel out हो जाएगा, subtracted. Okay, and next last properties from this. Before these examples we see, before this definition we see the examples. Differentiation of A minus B and B minus A, in both are different. A minus B is 5, we get a 5, and B minus A get a 4 and 5. Okay, so both are different, so we say A and B not equal to B minus A. Okay, this is our final properties. And mic is on. हाँ mic तो है, चल रहा है. Complement of sets. Now we discuss complement of set. Okay, 1 minute wait. यहाँ भाग रहा है. Complement of set ये sets of elements. set. नेक्स्ट टॉपिक हम लोग डिस्कस करते हैं कंप्लीमेंट. ये हायर स्टैंडर्ड में ज़्यादा यूज होता है और आपका आईआईटी में भी पूछता है सबसे क्वेश्चन. कंप्लीमेंट वाला हो गया सेट का. कंप्लीमेंट ऑफ सेट. कंप्लीमेंट ऑफ अ सेट. कंप्लीमेंट of a set. Complement of a set. What is complement of a set? Now again we understand right from example. What we take? Suppose a set U is given, okay, and a set A is here. A set is A. Complement means, listen here, when set A contains the elements in the circle, in this circle, all the elements सभी जो होते हैं, देखिए, all the elements of set A contains, set A contains in the representation only in the circles, but not outside on the circles. So outside elements say complement of A, because when A union complement of A gives universal set, that means complement set contains only those elements which are not belongs in set A. So we read the definitions of complement of the sets. Let's go. Complement of a set A is the set. This is also set. Is the set contains all those elements of the universal set, of this universal set, of the universal set of the universal set U which are not in set A, okay, and is denoted by, or it is denoted by, next, okay, and is denoted by A complement or A dash, that means A bar. Symbolically we write A complement or A bar equal to contains in this set those elements such that X not belongs in set A but X belongs in universal set, okay. This gives, and how we find complement elements from the given set and universal set. We find the complement elements, or A complement A dash also represent A complement. How we find? So subtraction used from universal set, okay, that means subtract element A from the universal sets. This gives our all universal complement elements of set A, okay. ये चीज हो गया, ये बोल रहा था, जैसे ले सकते हैं. For example, we take a universal set 0 1 2 3 1 2 3 4 5 6 7 8 9 digits. All digits are contained, all single digits are contained in the universal set. If, or let, here we write let, and set A 2 4 6 and 8, then find complement of set A. This implies A complement U minus A, means subtract those elements present in A 2 4 6 8 from the universal sets. Then we left 0 1 2 is cancel out, so 3 left, 4 is cancel out, then 5 left, 6 is cancel out, so 7 and 9 is our complement element, okay.